Alright, in this video presentation, we will be discussing the angle of inclination and the slope of a line. And then later on, we'll be solving some problems applying these two concepts. Alright, let's start with the angle of inclination. When we say angle of inclination, it is simply the smallest positive angle that the given line makes with the positive x-axis. So if this is our x-axis and this is our y-axis, and if we are given a line, say this is line L, right? And if we're going to locate the angle of inclination of this line, then we can say that this is the smallest positive angle that this line makes with respect to the x-axis, and usually it is denoted by alpha. All right, now suppose let's have another line here. Okay, and suppose this line is line N. Okay, let's change the color, line N. Okay, now if we're going to locate the angle of inclination of this line, then we can say that from the positive x-axis going to that line, then that is our alpha. All right, we can use this one, we can have it here, but we're going to change also the sign because we are now measuring the angle in a clockwise direction, so that will give us a negative alpha. Okay, now let's go to the slope of a line. The slope of a line is denoted by m. Okay, and it is simply equal to the tangent of the angle of inclination. So tangent of angle of inclination is denoted by alpha. All right, now suppose let's have a line here, and if we're going to solve the slope of the line of this line, let us try first to locate the angle of inclination of this line. So obviously, based on the figure, we can say that this is the angle of inclination. So let's change the color, say that's alpha. All right, now suppose we have 2 points here. Okay, this is point 1, and this will be our x sub 1, and that will be our y sub 1, and so this will be our p sub 1, x sub 1, y sub 1. All right, now let's have another point here. We have another point here, and this will be our x sub 2, and this will be our y sub 2, and so this will be our p sub 2 with coordinate x sub 2, y sub 2. All right, now let's do some projection here. Suppose we project this line, okay, in order for us to create a right triangle here. Okay, now we know, and if you have watched my previous video, I have illustrated this one when I derived the formula for distance formula. If this is our x sub 1, okay, if this is our x sub 1 and this is our x sub 2, we know that this distance is simply x sub 2 minus x sub 1. All right, and if we're going to get this distance from this point going to this line, that is simply y sub 2 minus y sub 1. All right, now if we're going to extend this line, okay, line okay, let's label this one as line L. Line L here becomes a transversal because of these two parallel lines. If this is line is if line L is a transversal, then we can say therefore that the corresponding angles created by this transversal are equal. And so if this is alpha, we can say therefore that this is also alpha, because these two are corresponding angles. All right, so if you notice now, tangent alpha here is now equal to tangent is opposite over adjacent. So opposite is y sub 2 minus y sub 1. And our adjacent here is x sub 2 minus x sub 1. Alright? And we know that tangent alpha is equal to m, which is the slope. So we can say that this is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Alright? So, if you have observed, we have expressed the slope in terms of coordinates. And so, if you are given of the coordinates, then we can use this formula to solve for the slope of the given line. Alright? So, this is the formula. Let's have some example. Find the slope and the angle of inclination of the line joining -1 and -5 and 7 and -4. Alright, so the first thing that we need to do here is to plot the points. Alright, let's start with -1 and -5. Okay, so -1 and -5 is here. This is the point. That is point 1, -1 and -5. Okay, and we have 7 and -4. So we have here 7 and -4 is here. Okay, this is 7 and -4, and say that's our P2. If we're going to connect these points, okay, that is the line, and so we're going to solve for that slope, for the slope of this line and the angle of inclination. All right, now let's note down the given. So we have x sub 1 is equal to -1 and y sub 1 is -5, and we have our x sub 2 equals 7 and y sub 2 equals -4. All right, now the formula for slope is again y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Right, and we know that y sub 2 is -4 minus -5, right? And this will give us 7 minus -1. Okay, and so this will be -4 plus 5, and this will be 7 plus 1, or 1/8. So that's our slope. Okay, so let's box it. Okay, now we need to solve for the angle of inclination. So angle of inclination is simply tangent alpha equals m, and our m is 1/8. So substituting tangent alpha equals 1/8, and since we're solving for the angle, then we can have the inverse of tangent. Okay, 1/8. Okay, and so take out your calculator. So let's have the arc tangent of 1/8. So arc tangent of 1/8. 1/8. All right, so it's 7.12. So very small angle. So alpha here is 7.12 degrees. Okay, so very small. So this is the angle of inclination. Let's have the last example. A line with a slope 1/5 passes through 6 and 3, and if the abscissa of a point on the line is 11, what is the ordinate? Alright, so we are to look for the ordinate of the second point. Alright, but we are given of the slope, which is 1/5, and the coordinate of the first point, which is 6 and 3, and the second coordinate is 11, but the ordinate is unknown. Alright, and so let's try to solve for the y. Now slope is simply y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the slope is given, which is 1/5. And we have the y sub 2, which is y, minus y sub 1 is 3 over 11 minus 6. Alright, so this will give us 1 over 5 equals y minus 3 over 5. Alright, so simplifying this further, we can actually multiply both sides by 5. Okay, and so we have 1 equals y minus 3. And so we have y equals negative 3 minus, no. It's y equals 1 plus 3 and y equals 4. Therefore, the coordinate of the other point is 11 and 4. Okay, so let's try to plot the points. So we have 6 and 3. 6 and 3 is here, and we have 11 and 4. So 11 is here and 4 is somewhere here. Okay, and so if we're going to connect the point, okay, so this is the line whose slope is 1 over 5.